As we continue our study of linear functions, one of the most important things to learn is slope. You may have learned it before, but we're going to review it now. When we talk about functions that we call linear functions, we are talking about functions of y in terms of x. That's all we mean when we say function. Talking about some variable y in terms of x. And if it's a linear function, we only have one x term, and the power of that x term is the first power. All linear functions have a graph that looks like a straight line. All lines have a slope, a steep slope, a very shallow slope, a positive slope, a negative slope, a zero, that should be horizontal, a negative slope that's really shallow, a negative slope that's really steep. Horizontal lines, if I can draw one, that is a zero slope. And then vertical lines have what we call an undefined slope, and we'll get into why. But slope is a measure of how steep that line is. How much does it go up? How much does it go over? You may have heard the phrase rise over run. Could go down and over. It could go down and backwards. It could go up and backwards. We'll talk about all those different things. But that's what we mean when we say slope. Slope is a measure of a line's steepness or slant. How we measure slope is between two different points on a line. So I'm going to give you the formula, and then we're going to talk about how to use that formula. The formula for slope between 2 points. So we are just calling this x1, y1 and x2, y2, meaning the x-coordinate of one point and the y-coordinate of that point and the x-coordinate of a second point. Slope is always found between 2 points by taking one y-coordinate and subtracting the other, and this is what's important, taking the x-coordinate that corresponds with that y-coordinate and subtracting the other. It is perfectly fine if you do y1 minus y2 over x1 minus x2. What matters is that the y units are on top, that the x units are on bottom, and that the first two go together. The first two go together. This is what we mean by rise over run. What we're really looking at is what are the change in the y-coordinates over the change in the x-coordinates. And if we remember the coordinate plane from the other day, the y-coordinates measure up and down, the x-coordinates measure left and right, and so you end up getting this. How far up and down are you going, and how far left and right are you going? It's also important to think about going up as positive and going to the right as positive, and think about going down as negative and think about going to the left as negative. A positive over a positive is positive. A negative over a negative is positive. Notice how that's also a positive slope. If we go up and we go backwards to the left, that would be a negative slope, up and back. Or if you went down and then over to the right, that would also be a negative slope. Let's do a couple practice problems with slope. I'll lead you through an example and then you try one on your own. An example would be find the slope between the point 3, 5 and the point 4, 7. Again, I don't care how you label it, how you do it, as long as you show the work clearly. If you call this x1, y1, and this is x2, y2, the formula for slope is to take one y-coordinate, y2 minus y1, over the x-coordinate, x2 minus x1. So now I'm just going to use the labels I have here. Y2 is 7, and I would subtract 5. X2 is 4, and I would subtract 3. And I would get positive 2 over 1, which is 2. If I graph those 2 points on a number line, on a coordinate plane, 3, 5, right here, 4, 7, right here, I'm going up 2 over 1, and if I connect those 2 points with the line, that line has a slope of 2. Now, I've been writing slope equals. We have an abbreviation for slope, and it's the letter M. And you may be asking, why are we using M for slope? Little history lesson. The original mathematician to study the coordinate plane, to invent the coordinate plane, was French, and his name is Descartes. And Descartes is a famous French philosopher, mathematician, Renaissance person of the late 17th century, I believe. Got to double check that. But he, being a French mathematician, did not talk about the word slope as we would in English. He talked about how a line climbs. How fast does the line climb? Does it climb up? Does it climb down? Does it climb quickly? Does it climb slowly? And the French word for climbing, the verb is monter. So M for slope comes from the French word monter. So the formula, slope equals change in y over change in x, or y2 minus y1 over x2 minus x1. All I can stress is that these coordinates go together, these coordinates go together, and the y is in the numerator. The x's are in the denominator. Let's take another example. Something like -3, 7 and 5, -1. Do this problem on your own, pause the video, and then we'll go over the answer. All right. Using the formula, change in y over change in x. 7 minus -1 over -3 minus 5. 7 minus a -1, that gives me a positive 8. -3 minus 5, that gives me a -8. When I get a fraction with a negative in the numerator, I just put the negative outside, or in the, a negative in the denominator. I just put the negative outside. 8 over 8 is 1. This line has a slope of -1. Again, if I graph -3, +7, +5, -1. I went down 8 and over 8. Down 8 and over 8. Or I went up 8 and backwards 8. Either way, I get a slope of -1. That means I could have gone down 1 over 1, down 1 over 1. Oh, it went too far. Down 1 over 1, 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 down 1 over 1. I could have done that 8 times. I could have gone down 4 over 4, down 4 over 4. Good? I could go up 3, back 3, up 2, back 2, up 3, back 3. Either way, I'm moving a slope of -1. There's two special cases when we deal with slope, and those happen when we have a horizontal line or vertical line. So let's take a look at what would give us a horizontal or vertical line in the coordinate plane. So here's the x-axis, which is horizontal. Here's the y-axis, which is vertical. I'm going to take 2 points, this point right here and this point right here, and they're a horizontal line through those 2 points. Now, it may not be as obvious for you to see it, but I hope this makes sense when I say if this is a negative x value and this is a positive x value, do you see that the y value here of maybe 4 has to be the same as a y value here of 4? So if we just use the definition of slope with those points, 4 minus 4 over 2 minus negative 3, I end up getting 0 over 5, which is 0. So all horizontal lines have the same y coordinates. All horizontal lines have a slope of 0. You could memorize that, but really I don't want you to memorize that. I want you to understand it. Because there's no rise, the slope has to be 0. We go up 0 and then we can run 5. We can run 1. It doesn't matter how far we run, we're going up 0. Good? The other special case is when we have a vertical line. So again, if we take a look at coordinate plane, this is the x-axis, this is the y-axis. I put a point here and a point here, and I draw a vertical line between those 2 points. I hope for the exact same reason with the horizontal line, but different variables, it makes sense that the y-coordinate here would be positive, like 6, and the y-coordinate here would be negative, like negative 5. But the x-coordinates would be the same, so this would be 3 and this would be 3. So if we go through the definition of slope and we try to take 6 minus negative 5 over 3 minus 3, we now get positive 11 over 0. Just a reminder, when we try to divide by 0, we get a problem. Let's take 5 divided by 0. If we say that's equal to 0, which is the common answer, what that means is 0 times 0 is 5. Is that true? No, of course that's not true. Alright, well if I said, okay, it's not 0, it's 5, well then what I'm saying is 0 times 5 equals 5. And again, that's not true. That doesn't make sense. So here's the problem. 5 divided by 0, if that equaled a number, then we're saying there exists some number that when you multiply by 0, you get 5. And that's absolutely impossible. So when you get something like 11 over 0, what we say is that this is undefined. And if you want to abbreviate that, UND, most mathematicians will know that UND means undefined. You can't divide by 0. So the vertical line here, we actually say has no slope, or has a slope that's undefined. There is no slope because you're going up and whatever you want, but there's no run, and we can't divide by 0. I've given you lots of examples with nice numbers, so I want to give you one more example with not so nice numbers. Let's say we have the point 0, 6, and we have the point 4, 0. Be careful with how you label these, but try to figure out the slope from these 2 points. All right, just following the formula, 6 minus 0 over 0 minus 4. Or you could have done, change colors here, 0 minus 6 over 4 minus 0. Down here you get negative 6 over positive 4. On the left here you get positive 6 over negative 4. Both of those are equal to negative 3 over 2, or negative 3 halves. A positive divided by a negative is negative. A negative divided by a positive is negative. We reduce the slope. On the coordinate plane, we went from 0, 6 to 4, 0. We went down 6 and over 4. Or from this point, we went up 6 and back 4. That's the same as going down 3 over 2, down 3 over 2. That's the same as going up 3, back 2, up 3, back 2. Either way, we get this same slope. Good? This is a 3, this is a 3, this is a 2, this is a 2, 3, 3, 2, 2. All right. Do your best on your classwork. I miss you guys. I hope you're doing well. I can't wait for Monday next week. Back to a normal schedule. As always, peace.